Good morning.
Good morning.
Good morning.
How are you guys?
Good.
Nice to hear. People are, so I can say, arriving. I will check attendance right now. And after that, we will continue discussing trigonometric material. Let me have the textbook. I like to remind you what we did last time, and we will go from there. We talked, can you check with your notes, please? Is it what we did at the end? Guys, can you check with your notes, please? Can you hear me? Hello, I do not hear any reply.
Yes, we can hear you.
Yeah, I can hear you.
I say, can you check what you have at the end of what you have in your notes, what we covered at the end of the previous lecture? Is it problem number, what is the number problem? 49.
Yeah.
Okay. What about my plan for today? I'm planning to show few more problems from that section, and actually planning to start another new section today also. So, and I would like to disclose something right now about what is going on. Yesterday, I received an email from the head of our Science, Math, Technology department with the request to submit names of students who do not actively attend our classes. And I definitely did that. Thanks God that majority of students actually are attending our classes, because as you know, I'm having these classes at the exactly same time as we had according to our schedule during the regular part of our semester. But I submitted the names of students, including G numbers and class section and the class name, and why is he requesting that kind of information? Because this information was requested by the management of our college district, and I think this information will be submitted to counselors. Let's say if you are students from our Skyline College, it will be submitted to counselors in our college. So please be serious about that. Besides that, if you remember in your syllabus, you have the special rule. It is based on the number of absences which you can accumulate, because if you do not have many absences, and again, all details are in your syllabus, I will drop one lost quiz grade and one lost test grade at the end of semester. That's it. Now I'm going to read your names to check attendance, and we'll go from that. But I do not want to see you wasting your time. This why, can you please solve these two problems from your textbook. On page 192, and this is the section number 3.1, can you please solve problems number 43? Can you please write it down? 43 and 50. And I definitely will go over these problems with you as soon as I'm done with your attendance. So today is 14th of April, and the following students should be in my class. So Bryce.
Here.
Grisha. Alexia.
Here.
Stephanie. Hannah.
Here.
Andrew. Demeter. Demeter. Benjamin.
Here.
Kyra. Jesus.
Here.
Ariana.
Here.
Axel. Desiree.
Here.
Lila.
Here.
Bucky. Jessica.
Here.
Ivuna.
Here.
Devin.
Here.
I saw Devin's names first, actually. Valeria. Valeria. Okay. So. Let's start with problem number 43. It is on page 192. I'm going to copy the problem right now. It is arctangent composed with tangent 4 pi over 5. Okay. Can you see well?
Yes.
So this is a composition of two inverse to each other functions. Is it true?
Yes.
Where should you look at now after you answered yes? Should you look right now at 4 pi over 5?
Yes.
Yes.
And what kind of question should we ask ourselves?
Is it within the range
Of which one?
of tangent?
No, arctangent. What is the outside symbol? Is it arctangent? Yes? So arctangent, let's see. Again, I think for many students it is easier if we can do estimation in, let's say, degrees. Pi is 180. Pi over 5. What is the value? You just need to simply divide. You can use even your calculators. You can divide 180 by pi, and it can be done even without calculator. 150 divided by 5 is 30. By 5 is 30. 30 is left to 180. 30 divided by 5 is 6. So if you divide 180 by 5, it is 36 degrees. But you need to multiply by 4. If you multiply 36 degrees by 4, 4 times 30, it is already 120, times 6, it is 24, so it will be 144 degrees. 144 degrees. Is it in the range of arctangent? Yes or no?
No.
No, it is correct. Because what kind of quadrants do we have in the range of arctangent? Is it only first and the fourth, not even including endpoints, right?
Yes.
So which means answer here is not 4 pi over 5. So we need to do something, changing this to another form, which will bring us to the step where we can see that inside value of x will be in the range. Let's talk about 4 pi over 5. On the top, you have, you have 4 pi. Which number close to 4 is divisible by 5? Is it 5?
Yes.
Yes.
Can I, instead of 4 pi, actually write down that it will be 5 pi minus 1 pi?
Yeah.
So let's write it down. So please copy arctangent, copy tangent, but instead of 4 pi, you will write 5 pi minus 1 pi over 5. Visually, it looks different, but mathematically 4 pi over 5 or 5 pi minus 1 pi over 5, they are equal to each other. But now I will continue simplifying that fraction which we have inside to write it in the different form as a sum or difference of certain angles. What do we have on the top? It is 5 pi minus pi. So which means each of these components I need to divide by 5. Let's start. So what I'm doing, arctangent, tangent, I'm opening parentheses now. 5 pi over 5 isn't just pi.
Yes.
Now I'm dividing negative 1 pi by 5. Is it pi over 5?
Yes.
So which means now you have in parentheses pi minus pi over 5. Excellent. And now let's simplify that. You can simplify this expression which you have in brackets in different ways, because it is a tangent now inside of brackets of pi minus pi over 5. So one method. What is the period of the regular simple tangent? Is it pi? Is it pi periodic?
Yep.
Yes.
So which means, according to this property, we can drop that pi without any problems, and we will be left with negative pi over 5. One method. Second method. Do you remember we applied the rule, we used actively the rule when we used vertical quadrantal, horizontal quadrantal, we can use the second method. And let's see what can be done here. Pi minus pi over 5, which is equivalent of 36 degrees. Pi minus that angle, is it an angle in the second quadrant, or it is actually 144 degrees angle? Is it from, ladies and gentlemen, can you please carefully listen and reply to my questions? Is that angle pi minus pi over 5, which is equivalent of 144 degrees, is located in the second quadrant?
Yep.
Yes. In the second quadrant, tangent is positive or negative?
Negative.
Negative.
Negative. So, which means tangent of this angle in parentheses will be negative. Now, in that parenthesis, do we use vertical quadrantal angle? I'm talking about pi, or horizontal?
Horizontal.
Horizontal. With horizontal angle, do we keep the same name of the function or we change it? Keep. So which means that expression which you have in brackets will be equal to negative, because tangent is negative in the second quadrant. It will be negative tangent of pi over 5. This is the second method. In the first method, if you like just to use that information about tangent being pi periodic, first step will be dropping this pi, so it will be tangent of negative pi over 5. In the next step, you will be using that property that tangent is the odd function, and you will take this minus all the way out. Which method? I don't want to show both because you need to choose or first method or the second. Which method do you want to use for this particular step?
The second.
First method, using property of periodic pi periodic function, or second method when we use vertical or horizontal quadrantal angles?
Second method.
Second method. Okay. In this case, you need to put equal sign, continue. You are writing tangent minus 1, which is arctangent. And now, as we already discussed, and I do not mind discussing this one more time, I am discussing like what? Pi minus pi over 5. It is different visual form for 144 degrees. 144 degrees angle is located in the second quadrant where tangent is negative, so I'm writing minus sign. In parentheses, where I had pi minus pi over 5, I used horizontal quadrantal angle, so I keep the same name. And I don't mind now what I have in parentheses. Plus angle, minus angle, doesn't matter. It will be tangent of the reference angle. Reference angle here is pi over 5. This what I'm getting. It will be arctangent minus tangent of pi over 5. And now I can continue again because I really like to do something with this minus. And what can be done with this minus? We already covered that particular problems. Do you remember? We had, I kept this paper. We covered this while ago. Do you remember what we had with arctangent of minus x? Can you see? We can carry this out. Yes? I'm going to carry this minus all the way out. So, and it will be minus arctangent of tangent pi over 5 minus arctangent of tangent of pi over 5. And now I am again writing minus down. And now I will discuss the rest what I have after this minus. Just pay attention to this part, arctangent of tangent of pi over 5. Is it a composition of two inverse to each other functions?
Yes.
Yes.
Pi over 5. Pi over 5 is equivalent of 36 degrees. Is it in the range of arctangent?
Yes.
Yes.
That's it. What would be the answer now here?
Negative pi over 5.
Right? It is negative pi over 5. And we reached quite easily, definitely. It took a little bit longer time because we discussed every single step. If you don't need to discuss and you know the material, it really will take just maximum 1.5 minutes to finish the entire problem. Is it clear to everyone how we reached that answer?
Yes.
Yep.
Should I go over that again, or it was good enough for you and I can move to the next problem?
Next problem.
Next problem, okay. What do we have in the next problem? Next problem, as I remember, was problem number 50, right?
Yep.
Okay, so this one was 43. Now it is 50. Let me copy number 50. It is again, it is a composition. The only, now it is a different type of composition. The outside function is so-called direct function, but inside or interior function is our arc function, which is arc sine, inverse sine. And again, what should we do here? We need to find the exact value, excuse me. We need to find the exact value of this composition. Sine composed with arc sine of -2. Okay. Are you ready to start our discussion?
Yep.
Do we have maybe someone who already solved this problem? Maybe you can recommend us something? Do you see anything special here? Did you ask yourself these traditional questions about composition of inverse to each other? Is the inside value of x in the range of outside function? Can you please help us to start the problem? Don't be extra shy, guys. You should know what to do. Who is the bravest person? Nobody? Okay. Can I ask you some questions? Please try to answer. Is it a composition of inverse to each other functions?
Yep.
En clase, bueno, la cosa es que no me venga así, no importa. La cosa es que se hacen de la manita.
Excuse me, I cannot hear what you are talking about. So I just heard some people had said yes.
O sea, que creo que les pasa a ustedes, no sé.
Excuse me, guys, I can hear your private. Guys, I can. Ladies and gentlemen, we have a class. I can hear your private conversation. Don't do that.
Que habían pasado con chicos y va así, yo le dije, sí, pues, o sea, sí sabías que, tú sabías que había pasado. No, no exactamente qué cosa, pero sí. Y se me molestó horrible, yo le dije.
We are using only English right now. I can speak 5 languages. I can start with anyone, but it will be not polite to other people. We are now using that language, which is good for everyone. Please. So what do we have here? Is it a composition again of 2 inverse to each other functions? Yes. Is -2 in the range of sine function, the outside function? In other words, can sine of any angle be equal to -2?
No.
No.
No. Yes, it is correct. So what would be your verdict here?
Would it be undefined?
Definitely, it is undefined because there is no answer. Yes, it was a composition of inverse to each other functions, but unfortunately, -2 is not a good number for us because sine for any angle only can fluctuate between -1 and +1. Any number between -1 and +1, including both ends, are okay, but all other numbers which are outside of this interval from -2 to +2, or excuse me, from -1 to +1 is not okay. And -2 is outside of that interval, close interval between -1 and 1. This is why there is no answer. There is no answer. Undefined answer does not exist. I just used small symbol to write. This is the symbol of existence, and I cross this out, which means does not exist. This answer here is not existing. In other words, undefined. Did you understand how to work with that problems? Yes?
Yes.
Nice. English has two magic words, yes and no.
Yes.
Yes.
Excellent. Let's continue. I'm going to solve first time right now one of equations from trigonometry. It is quite easy. We will be solving many equations, but this will be the first one. And I'm jumping over one of spots. I will come back to that definitely. And I'm talking about the spot from number 61 to number 68. And what should we do here? It is being stated here. In problems from 61 to 68, find the exact solution of each equation. And let's say I'm solving problem 62. I'm going to copy right now 2 arc cosine of x equals pi. 2 arc cosine of x equals 2 pi. Why can we call it as an equation? Look, do we have an equal sign?
Yes.
Yes.
Do we have an unknown?
Yes.
Is it x?
Yep.
That's it. We have two required components to call this mathematical sentence as an equation. It has its own equal sign, and it has at least one unknown. And we have this unknown. This is variable x. We need to solve. What do we do solving any equation which has x as an unknown? Should we find the x value which should satisfy this equation?
Yes.
Look at this, your equation. Is it locked inside of the arc cosine symbol?
Yes.
Yep.
Yes.
Do you see that coefficient 2 in front of arc cosine?
Yeah.
Yeah.
What would you do here to start the problem? If you have, let's say, 2a or 2x, let's say, equal to 10, what do you do?
Divide both sides by
Divide.
2.
Exactly why we cannot do that here. 2 is a coefficient for arc cosine, which means 2 arc cosines of x equal to pi. Can we divide both sides by 2?
Yeah.
Yes.
Yes.
Let's do that. After we did that, we are getting new version of that equation. Is it now arc cosine of x equals to pi over 2?
Yes.
But what kind of symbol do you have here? Is it the symbol of inverse cosine? Yes?
Yes.
Yep.
What can neutralize the symbol of arc cosine? What is its inverse function?
Cosine.
Cosine.
Is it a regular cosine?
Yes.
Yes.
Take this cosine, apply this cosine, excuse me, to both sides as a composition. So it will be cosine composed with arc cosine, but if you did this on the left, you need to do the same thing on the right. If you did this on the left, you are doing absolutely same thing on the right. So now on the last line, what do you see here? You see a composition of cosine with arc cosine of x. Are they inverse to each other functions?
Yes.
So, and we here all the time assume that it should be that situation when this x is in the range of outside function. In this case, what would be the value on the left after you apply this knowledge, this information? Is it just x?
Yes.
So, and you are getting x equals cosine of pi over 2. But it is not the answer yet. Why? Because we have on the right side cosine of pi over 2, or if you like, it is cosine of 90 degrees. But you need to be able to operate with angles and in degrees and in radians. What is the value, ladies and gentlemen, of cosine of pi over 2? I cannot hear.
Below.
Right. And look, I even already boxed the answer. X is equal to 0. And we solved that equation. Did you write it down?
Yes.
Please box it. That's it. You are done with this particular problem. What kind of steps did you take here? First, you got rid of coefficients in front of arc cosine, dividing both sides by this coefficient. In our case, it was 2. After that, you got what? That arc cosine of x was pi over 2. You need to release that x. What can be done here? You can use the composition of with the function which is inverse to arc cosine. For arc cosine, inverse function is the regular cosine. You applied cosine to both sides as a composition. And this step lets us release that x value, and we applied another step here, thinking about exact value for cosine of pi over 2, which we covered long time ago. This why we ended up having the answer x is equal to 0. I can solve, this is quite short spot, so I can solve one more problem from this spot. Can you please precisely look at these problems from 61 to 68, and I already solved number 62. You can choose from this spot your problem which you like to see right now, and I will solve it for you. Which one?
Can we do 65?
Yeah, I can
Oh,
do.
I meant 66, sorry.
66?
Yes.
Okay, definitely I can. What about the rest of the class? Are you okay? I'm going to solve number 66 right now.
Yep.
Let's do it.
Okay, let's do that. So again, same page, page 192. Page 192. Problem is number 66, and I'm going to copy this problem. 3 arctangent of x equals to pi.
What?
Oh no, I really apologize. I copied incorrectly. I copied 65. I really apologize. I'm going to rewrite this right now. -4 arc tangent of x equals to pi. Oh my God. My apologies. I really can you check if I copied correctly? -4 arctangent of x equals to pi.
Yes.
Okay. Is it an equation?
Yes.
Is it carrying inverse tangent?
Mm-hmm.
Okay. Does it have its own coefficient in front, which is -4?
Yes.
Yes.
What would you do here?
Divide by
Divided by
-4.
-4.
Absolutely correct. Both sides divided by -4. First step, which releases arctangent. And now we have a slightly new form. Arctangent of x equal to -π/4. What would you do as a next step?
You should cancel out arctangent by multiplying both sides.
It is not a multiplication, it is a composition.
Sorry.
You are correct, only change one word. Can you repeat now with correct word, please? Apply,
Apply the composition
right,
to both sides
of which function?
of tangent.
Tangent, right. So it will be tangent composed with arctangent of x and tangent of -π/4 on the other side. Please use parentheses around -π/4. And now let's look first at the left side. What do you see on the left side? Is it a composition of inverse to each other functions?
Yeah.
Yep.
And here in this method, we assume all the time that this x is in the range of the outside function. Keeping in mind these two important details, what can we say about the left side after we discuss that? It will be equal to what?
X.
X, definitely X. So which means X is equal to tangent of -π/4. Now, tangent of -π/4, what can we do with tangent of -π/4? Can we simplify this a little bit?
Can it be x equals negative tangent?
It should. You are giving me very good advice, definitely, because tangent is one of odd functions, right?
Yes.
So this minus should migrate. It should come to the front. So, and now we have only one step left. So I wrote already x equal to negative number.
1.
And it will be tangent of π/4, which is equal to what?
1.
1.
Yes. So, and we're done. So you can box this answer. X is equal to -1. So we are done. Do you understand?
No sé nada, Dani.
Do you think that these problems are really heartbreaking problems, or they are quite easy if you know definitely what you do?
They're okay.
They're okay.
Yeah.
And now there is only last spot left here, which I'm planning to work with. And this is the spot from 53 to 60. And here are different type of problems. Yes, it is again about direct functions and their inverses, which are arcuses. And I'm going to read here. In problems 53 to 60, find the inverse function f minus 1 of each function f. Find the range of f and the domain and range of f minus 1, which means inverse. Let's say that here We will choose some problems. Let's say this is, no, we can choose any problem. Are you okay with, let's say, problem number 53?
Okay.
Okay, let's copy problem number 53. Did you write it down? Actually, if you like, I can do 54. What do you prefer, 53 or 54?
54, son.
Okay, 54. 54. Method will be the same, only there will be just different problems. Okay, I'm going to copy that problem. Given function f at x equals 2 tangent x minus 3, comma, x is between negative pi over 2 and pi over 2. If I were you, I would even show right now this interval to which this x belongs. You can see x is greater than negative pi over 2, but it is less than pi over 2. So what practically we have here? We have here half of this circle and no ends for that half. So negative pi over 2 up to pi over 2. I will shade right now that half of the circle. So x belongs to that shaded region, which is, can we say that it is the right half of the circle?
Yes.
Does it remind you anything?
Of sine or arc sine?
Is it a range for arctangent?
Yeah.
Yes.
Yeah, arcsine also has a right half, but it has endpoints included. Do you understand that?
Yes.
We will have not open circles at the endpoints. We will have dots. Can you see we have here open circles?
Yeah.
So, and let me show that. 1 second, please. This is the old paper, and can you see it is right here when we wrote down that information about arctangent?
Mm-hmm.
Okay, so I just reminded you that. But now let's discuss what we have here. The function is f at x. And we have here in this shaded region information, we have an information about how x is changing. X can be changing only between negative pi over 2 and pi over 2. What kind of information do we have knowing that interval? Ladies and gentlemen, it means that domain of this function which was given in this problem is your open interval from negative pi over 2 up to pi over 2. This is the domain. This is the domain of that function f. Can you see? I even wrote d with index f, which means it is a domain for function f, because domain all the time tells us about values of x. And in this problem, values or information about values of x was provided. So far, so good?
Yeah.
Now, let's talk about the range of that function. Range for function f, original. Please think about just y equal to tangent. Tangent x. We covered tangent x as a function long time ago. We covered the function, we covered the graph of that function. Do you remember? Graph of the tangent could be continued forever from negative infinity to positive infinity, right?
Yeah.
Yep.
So which means in our formula for f, we have that tangent, and this tangent can fluctuate between positive infinity and negative infinity because it is an infinite graph vertically. Now, let's see how this tangent is participating here in this formula. Should we multiply tangent x by 2 and subtract 3 from the result?
Yes.
What happens if you have an inequality and you are multiplying all sides of inequality by any positive number? Should you change symbols of inequality or you keep them?
You change them?
No. Only if you are multiplying all sides of inequalities by negative number, you need to switch signs of inequality. If we had less, it will be greater. If it was greater, it will be less. But if you are multiplying all sides of inequalities by positive numbers, you are keeping same symbols. And listen, if you multiply negative infinity by 2, the result will be again negative infinity. If you multiply positive infinity by 2, result will be also positive infinity, because infinities are, it is not a regular number, it is a process that numbers can go, let's say if it is negative infinity, it can go to the left without any stop, just moving more and more and more to the left. On, let's say if it is approaching positive infinity, it just can keep going and going and going without any end to the right. So which means if we multiply both sides by 2, we are getting same symbols practically, not changing anything. It will be now 2 tangent x in the middle, but negative infinity and positive infinity will stay the same. Now, I again look at the formula. So we are now much closer than we were before to what we had for f at x, because we had 2 tangent x, but now we need to subtract 3. We need to subtract 3 from all parts of this inequality. And let's see what can be done here. So in the middle, you will be having now 2 tangent x minus 3. And what you do, you are subtracting 3 from all sides of this inequality. It will be negative infinity minus 3. In the middle, 2 tangent x minus 3. And on the most right side, it is positive infinity minus 3. Now, let's logically think about the meaning of positive infinity minus 3. What do you think? What would be the answer for positive infinity minus 3?
That still be positive infinity?
Definitely, because negative 3 is practically nothing comparable with positive infinity. Positive infinity is such a large number which can become larger and larger, larger and larger, that negative 3, yeah, I could have here even 3 millions, but even if I have positive infinity minus 3 millions, the answer will be infinity, positive infinity anyway. So which means 2 tangent x minus 3 is less than positive infinity. And now I can talk about other side. What about result for negative infinity minus 3? What would be the answer for negative infinity minus 3?
Won't it be negative infinity?
Definitely it will be. It will be negative infinity. What do you have inside? Is it f at x? I'm talking about 2 tangent x minus 3.
Yes.
So, which means now I know that my function will be changing or fluctuating between negative infinity and positive infinity. Is it actually an information about the range of that function only given as inequality?
Yep.
So that's it, which means I can write down now that information, and I already found one of answers, because in this problem we were asked to find the range for f. This is the range for f, but now we need to find 2 more things: domain and range for f minus 1. But because now we have both domain for f and range for f, I very easily can write down information about domain and range for inverse function. Why? Because when I started explaining you this material, I told you that this domain and ranges for a function and its inverse, they have like cross relationship. Domain for the first one will be the range for the second one, and the range of the first one will be a domain for the second one. So, in which I am going to write down, and in this case, domain for f minus 1 will be equal to the range for f, and I am going to show you right now what I wrote down already on the paper, and you can do the same thing. And you can see these boxes, which means that domain for f minus 1 is equal to that interval from negative infinity to positive infinity, which is same thing as R for f. Can you see?
Yes.
And now, in the same manner, absolutely in the same manner, I will write down that line about R for f minus 1, which is the range for f minus 1. According to this relationship, it will be equal to the domain of function f, and domain was given actually in our problem. So this is why it is the easiest part. Here, I spent definitely some energy and time to find the range for f, but domain was given. And after I was equipped by domain and range for f, I just simply write down that the R for f minus 1, which is actually equal to domain for f, will be equal to that interval from negative pi over 2 to pi over 2. And we found all these 3, because there were 3 questions about range for f and domain and range for f minus 1. But I'm not completely done, because now I need to find a formula. I need to find a formula for our inverse function. It will be the last step right here. Are you with me?
Yep.
Yes.
We need to recall material about inverse to each other functions, which was in your 120 class. What should you do here? I'm going to write down again that formula for the given function, and I'm starting the process of doing what? Looking for the formula for it. You can see I just copied this right here. F at x equals to 2 tangent x minus 3, and I'm starting the process. Step number 1 here in this process, replace, you can write it even down like comments on your paper so you will know what to do. Replace fx by y, because y equal to fx. Y equals 2 tangent x minus 3. Switch x with y. Switch x with y. Everywhere where you had y, write down x. Everywhere where you had x, write y. But after you switched x with y, you are going to start a process of solving this equation for y. This y. I put comma here and I wrote y equals to question mark. And now you can do that exactly in the same way as we worked with equations. Our unknown is y. Pretend that x is a given number. Can I move -3 to the other side, changing the sign?
Yeah.
Yes.
Or add 3 to both sides, up to you. So x plus 3 equals 2 tangent of y. Can we divide both sides by 2?
Yes.
Divide by 2. Cancel 2's on the right side. And what you have here, you have tangent y equals x plus 3 over 2. Right?
Yes.
Where is your y? Is it locked inside of tangent symbol?
Yes.
What can you do here? Can you apply arctangent in composition to both sides?
Yes.
Did we do that in equations? Yes, we did. So arctangent composed with tangent of y equals arctangent of x plus 3. I applied arctangent as a composition on both sides. Can you see?
Yes.
We already know everything about domain and radius, and we build them in that way that they are good for tangent and arctangent. So this y, what do you have here on the left? Arctangent composed with tangent y. Are they inverse to each other function given in the composition?
Yes.
Is it y released right away here on the left?
Yep.
Yep.
So it will be y. Y equals arctangent of x plus 3 over 2. And the only one step right now left, you solve this for y. You need to simply rewrite this in more acceptable form. So in more acceptable form will be now replace y by f minus 1. So f minus 1x equals arctangent of x plus 3 over 2. It is quite a long process because we had many questions here, but each step should be quite transparent to you because we discuss domains and ranges, and we a priori knew about special relationship between domain and range of the direct function with domain and range of its inverse. And we used the regular process when equation for the direct function was given, and we used several steps to finally get the formula for its inverse. What kind of steps? If the function is given like fx equal to the formula, replace fx by y. After that, switch x with y and start solving what you got as a result of that as an equation to find y. In the process, we applied composition to get composition of inverse to each other functions, and finally simplified again and got our desired formula. This is a little bit long process, but it is a big problem and it has many steps because again, we had here questions about a range of the given function, domain and the range of inverse function, and the formula for the inverse function. But all these problems should be solved in the same way in this spot. What time is it right now?
11:16.
Okay, I'm declaring 5 minutes break right now, so I will start back when it is 11:21. Okay? And I will quickly right now read, if you already replied to my voice when I called your name at the beginning, changing attendance, I will do that one more time finally to see who is not here today. Others, if you already took care of that, you can already rest. So, Gracia, Dimitar,
Here.
okay, Axel, and again, guys, be very careful with your attendance because college is requesting that information, how you attend your classes. And I cannot lie to them. So each time when they ask me about this information, I definitely will provide this information to our management. Okay. Okay. I promised to come back at 11:21, but now it's even 11:22. Ladies and gentlemen, I'm going to start another section. So please try to finish your homework for 3.1. Do you remember that information about the due date for 3.1 homework?
16.
Excuse me?
16.
16.
16. Okay. So you still have some time, but try to finish because I'm planning to post another quiz only for material for 3.1, and I will be posting this probably today, but I think I will make it available for you starting actually tomorrow. Okay, but what about section 3.2? Section 3.2 is another section from chapter 3, which is devoted to inverse functions and compositions. If you look at the topic, I can even show it to you in the textbook. It says right here, the inverse trigonometric functions continued. You can see that even in the textbook. Yes, this material is being continued. And we need to use everything what we learned in 3.1 here, but at the same time, it will be a slightly different type of approach because not all the time we will be dealing with compositions of only inverse to each other functions. Again, there will be quite many similarities. At the same time, there will be a quite big room for different methods. What I'm going to do, I'm going to go right now directly to the exercise page. So if I were you, I would probably write down the topic, which means the inverse trigonometric functions. In parentheses, you can write down compositions of not only inverse to each other functions, or you can write down, as the book actually recommends, continued. The page which we need to start with, working with problems, is 198. Page number 198. And I will start with first part, and I will slightly go down. It is here, material continued on page 199 and etc., but we don't need everything. This is not a, let's say, here, not too many problems, but some of them can be quite challenging. This is why from each spot, and spots here are quite big, I will be solving quite many problems. Let's say the first problem, which I'm going to start with, is problem number 10. It is again on page 198, problem number 10. Let me copy that problem. And I will continue working with these problems to the end of our today's class. Please check if I copied correctly, and I'm going to read what should be done here. It says here, it states in the book, it is being stated, excuse me. In problems from 9 to 36, find the exact value of each expression. And the expression is, it is a composition of sine with arc cosine of 1/2. Did you write it down?
Yes.
Precisely look at this composition. Do you see a huge difference in these compositions comparable with previous compositions?
Yes.
Is it answer no on the first question? What was the first question? First question which we asked ourselves in the previous section was, is it a composition of two inverse to each other functions?
Yes.
And our answer is no.
Mm-hmm.
For this case. So which means we cannot use exactly step-by-step same method which we used before. Question is, what should be done? And I'm going to show what should be done here. First, do you understand that all arc functions like arcsine, arccosine, arctangent, arcotangent, etc., there are arcuses. Arcuses means angles. They are angles because direct functions are ratios, there are numbers. So direct sine, cosine, tangent, cotangent of angle theta, they are numbers. But in the inverse functions, numbers which were functions, they become independent variable. In the direct functions, independent variables, they were angles. Now, in inverse, angles are becoming functions. So all inverse functions are angles. And what you have here inside is that arc cosine of 1/2.
Yes.
This arc cosine of 1/2 is the main angle for which cosine is equal to 1/2. It is the angle. So look what I'm going to do. I will write down, let's say, let arc cosine of 1/2 be theta. Which lets me rewrite the original problem in different form. Can I write now that this actually should be sine of theta? I cannot hear you guys.
Why is it
Yes.
theta?
Because I replaced arc cosine of 1/2 by theta only. Can you see after sine symbol in parentheses, you have arc cosine of 1/2?
Yes.
So what I have in this parenthesis is now theta. It is angle theta.
Oh, yeah.
In other words, what I did, I just replaced what I had in parentheses by theta. Can I?
Yes.
Yes. But now I'm going to discuss everything what I see on this line, that arc cosine of 1/2 is theta. Look at this 1/2. By the way, what is the range for arc cosine? This is which half of the circle? The right one, the top one, which one?
Sorry, can you repeat that?
What is the range for arc cosine?
Part.
Pi to 2 pi.
No, all the time, we don't have 2 pi in any of this range. I'm asking about half of the circle, but which one? Is it the right half of the circle or the top half of the circle?
The top half of the circle.
Top half of the circle. Top half of the circle contains two quadrants, number 1 and number 2. That this is cosine, in this case, is 1/2 positive, 1/2. So out of these two quadrants, number 1 and number 2, which one would you choose if cosine is positive, 1/2?
Quadrant number 1.
Definitely, because in the second quadrant, cosine is negative. So which means having in my mind that theta is arc cosine of 1/2, I already know that theta can belong only to the top half of the circle, but at the same time, I can be more specific because I see that positive 1/2. So which means theta belongs to the first quadrant. Theta belongs to the first quadrant. And now it is a lot. I already have quite powerful information because first, look at this arc cosine 1/2 equal to theta. Can we apply cosine as a composition to both sides? Guys, did we do that already in other problems?
Yes.
Why we cannot do that here? Can we? Yes, we can. We can apply right now cosine in composition to simplify that case. So you can see new symbol cosine on both sides. Now it is not just arc cosine of 1/2 equal to theta. It is cosine composed with arc cosine of 1/2 equals to cosine theta. It is not a multiplication. It is cosine composed with arc cosine of 1/2. And again, I will start asking myself the following questions. Question number 1. Is it a composition of two inverse to each other functions?
Yes.
Is 1/2 in the range of outside function?
Yes.
Yes. In this case, what would be the value on the left side? Isn't just 1/2?
Yep.
So, and what you are getting? You are getting 1/2 equals to cosine theta. So I already know that cosine theta is 1/2. At the same time, I know that theta is from the first quadrant. I will even box that information to make it more visual. So now I have cosine of theta equal to 1/2. I am boxing not because they are answers. They are not answers, but it is these two pieces are very powerful pieces of information. Theta belongs to the first quadrant, and at the same time, cosine theta equal to 1/2. Look at the first line right here. What do we need to find? Can you see? We are looking for sine of theta. Now, I will rephrase right now this problem, which means here what? We need to find sine theta if we know that theta belongs to the first quadrant and cosine of theta equal to 1/2. We solved many of these type of problems in chapter 2. Why? Because I will remind you, do you remember the formula? We call it the main trigonometric identity, that sine square of theta plus cosine square of theta equals to 1.
Yes.
Yep.
I will be using that because from that formula, applying this formula to this case, I can find the answer. So I'm writing down sine square theta plus cosine squared theta equals to 1. I'm going to replace cosine by 1/2, so it will be sine squared theta plus 1/2 squared equals to 1. I easily can raise 1/2 to the second power, and with your permission, can I combine two steps in one step? I will raise 1/2 to the second power, which will be 1/4, and we'll move it to the right side, changing the sign. Is it okay with you?
Yes.
Guys?
Yeah.
Okay. It means sine squared equals 1 minus 1/4. 1 minus 1/4. Is it 3/4?
Yeah.
And I'm getting sine squared theta equals to 3/4. But I don't need sine square of theta. I need sine of theta in the first power. What should I do?
Square root.
On both sides, right?
Yep.
Do that. Square it on both sides. Square root of sine squared theta releases sine theta, but anytime when we take square root in algebra, in mathematics, we need to consider two signs, plus and minus. But if we have a location of theta, and theta, as we know, is from the first quadrant, I can choose or plus or minus for the answer. If your theta is from the first quadrant, which sign should I use here? Plus or minus?
Positive.
I cannot hear.
Plus.
Plus.
Definitely plus. So which means it will be up to you to write this plus or not. Square root of the 4, which is on the bottom, is it just 2?
2.
And voila, you actually solved this problem, because now you have your answer. Because in this problem, we were asked to find sine of theta, and we have already this answer for sine of theta. It is positive square root of 3/2. We solved this problem completely. Can you see all steps?
Yes.
I'm ready to answer all questions which you can have. Look precisely at what we did. We asked ourselves the traditional question, if at the beginning we had a composition of two inverse to each other questions. Answer was negative, no. This is why we could not use the same method which we applied in 3.1. We used another strategy. We rewrote our original problem in different form. Instead of sine composition, we wrote this like sine of theta, where theta was the inside piece of that composition. And because it was our cosine of positive 1/2, we concluded that theta should be from the first quadrant. We found the value of cosine of theta. It was 1/2. We applied a well-known formula, sine squared theta plus cosine squared theta equal to 1, because in this formula we had both sine and cosine, and which lets us treat that formula now as an equation where sine theta was our unknown, and we solve this equation for sine of theta. And answer is our answer here for this equation, and solution is the answer for our problem. Which problem from the same spot, but from 13 to 16, you like to see right now being solved? I will be doing this quite quickly. What about number 14? Is it okay?
Yes.
Okay, but I will be quite quick because I don't have enough time. So what I'm going to do, I'm going to copy. Is it a cotangent?
Yes.
Of what? Arc sine of negative 1/2. And I'm going to proceed in the same way. Is it a composition of two not inverse to each other functions?
Yes.
Make inside piece equal to theta, because it is the angle. Arc sine of negative 1/2 equals that theta. Now, what is the location of that theta? Is it arc sine function? What about the range for arc sine? Is it the right half of the circle?
Yep.
Yes.
Which means first quadrant, fourth quadrant, including the endpoints. But is it negative 1/2?
Yeah.
If you have first quadrant and the fourth one, for negative 1/2, which one would you choose, first or the fourth?
Fourth.
Absolutely correct. Theta belongs to the fourth quadrant. So which means now I'm going to rewrite my original problem in different form. It now will be equal to cotangent theta. So practically, if somehow I can manage to find cotangent theta, it will be my answer. What I'm going to do, I'm going to right now apply sine as a composition to both sides for that theta. Sine, arc sine of negative 1/2 equals to sine theta. On the left, is it a composition of two inverse to each other functions?
Yes.
Negative 1/2, is it in the range of outside function? Yes. Is it smaller than negative 1? Is it between negative 1 and 1?
Yes.
Yes. So which means the left side is negative 1/2. Negative 1/2 is my sine theta. So now I have two pieces of very powerful information. So sine of this angle is equal to negative 1/2. Theta belongs to the first quadrant. Cotangent theta, is it cosine theta over sine theta? Yes. So which means if I somehow can find cosine theta, finally after that I can find cotangent. I'm using same formula as I used before. Sine squared plus cosine squared of theta equal to 1. Now, instead of sine, I will use negative 1/2 because it is the value of that. Negative 1/2 squared plus cosine squared theta equals to 1. Negative 1/2 squared, is it positive 1/4?
Yes.
So, and I'm going to move it to the other side. I'm getting cosine squared theta equal to 3/4. Cosine squared theta equals to 3/4. But cosine squared equal to 3/4, and theta belongs to the fourth quadrant. I'm going to take square root on both sides. And now, ladies and gentlemen, and you remember here should remember that theta is from the fourth quadrant. In the fourth quadrant, cosine is positive or negative?
Positive.
Positive, so which means it will be plus square root value. So cosine theta equals positive square root of 3/2. This is your cosine value. Excellent. Now the last stage, cotangent theta equals cosine theta over sine theta, which is the formula for cotangent theta. And now I have values for cosine theta and for sine theta. I'm going to plug. So it will be cotangent theta equals, on the top, square root of 3/2. On the bottom, negative 1/2. Result is negative, and it will be square root of 3/2 times negative 2/1. I converted this into multiplication by the reciprocal. Positive by negative is negative. I can cancel 2 and 2, and what is left is my answer for cotangent. Then I'm going to box in cotangent, and this is my answer for this problem. Did you understand how answer appeared right here?
Yep.
Yes.
Yeah.
So you can see I used here many steps, and I found many different details, applied 2 different formulas, but everything depends on the problem, because sometimes it can be a little bit less steps, sometimes it can be a little bit more steps, but the process is quite identical for all these problems in this section. Definitely the next time I will be solving more and more problems from this section 3.2. And this is quite challenging material, and it is a very important material for upper level of math. Please do not miss the next time lecture. With your permission, can I end today's
Okay.
Yes.
Yeah.
class? And as always, I will try to post this on YouTube. And I would like to ask you if you watch that videos on YouTube, because I saw some people, a number of people. Is it helpful for you?
Yes.
Okay. In this case, everyone have a nice, beautiful day, and I will see you the next time.
Bye.
Bye.
Bye. Bye, guys.